Okay. Right. Hello, 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 everybody. Hello, how's everybody doing tonight in this fine evening? Well, there's still sun out. How's everybody today? I hope everybody's doing well. All right, got a couple minutes before things start popping off here. But hopefully everybody is doing fantastic. Hope everybody had a wonderful weekend nonetheless. All right. Hope we got a few people in here today. All right. Like I said, give me a couple minutes. We'll get started here. Today will be a short-ish type day. So hopefully you guys like a shortish type day. We're actually pretty ahead of the curve here, so but we'll wait for a few more people to start trickling in here. Then we'll go ahead and get going with whatever it is we have to do. Hopefully, good thing. Hopefully. All right. If anybody has any questions, just let me know, of course. All right, get a few more people in here. I'd like to think. Hey, Focus. Good evening to you. How are you doing today? How are we doing today, Focus? Are you doing good? How was your weekend, Focus? I hope you had a wonderful weekend. Hopefully it was good. You had a nice time. Make the dream work. I don't know. Can I unmute? I think so. Turn 21. Oh, I see. Well, the question I guess I should ask you, Focus, is do you remember the weekend? Because that's that's the overarching question anytime we write something like that. Yeah, exactly. Somehow, some way, magically, something last weekend. Next time I'm in conscious math class. I'm not sure what day today is, my man, but it's a day ending in day. You'll just have to kind of go along with it. I'm not telling, and you'll just have to find out for yourself. Oh man, I'm glad you had a lot of fun though. Glad you had a lot of fun. Congratulations on turning 21 over the weekend. Um, no, that's awesome, dude. Got to go out with, I'm sure, a lot of friends and had a nice time and everything. So absolutely, absolutely is a milestone in every young adult's life. So I remember when I turned 21. What happened when I was 21? Not much. I ain't gonna lie. What happened when I was 21? Yeah, not a whole lot. I was like a really boring dude back then. Dylan, my dude, the shirt's like, let me tell you. Dylan, I spent the past hour speed watching the last hashtag game yesterday. And yeah, let me tell you about that game against Malden and Tiptree. Yeah, let me tell you about that game. Let me the Dinky Winky effect. That was on display. Let me Jesse looked clean. That last minute goal was clean, but Lee Hurst's goal, man. Oh my goodness. Lee Hurst's goal is a thing of beauty. Woo! My goodness. That thing is disgusting. I watched that at least a good 4 or 5 times, and I still can't get over that goal. Wow. That is crazy. That Hurst goal is amazing. I'm gonna miss Josh Sude for 3 games. I'm gonna miss him. But I think he brings. I think having Josh back on the team just absolutely. I think it opens up the rest of the pitch for the other guys. I think you have to watch out for Josh's speed. He's so darn blooming fast that he opens up the rest of the press. But yeah, man, that was Dylan. I ain't gonna lie, that was a fun game to watch and a deserved 3 points. And we're finally off. We're finally off the bench. We got our 3. I remember first game of the season was arguing with some random so-called hashtag because he was saying Malden and Triptine gonna bat it. They won 7. Look, what was it? What was it? A season ago or 2 seasons ago, right? Wasn't didn't Aston Villa batter Liverpool like 7-8-2? Was it like 8-2 or something like that? I mean, and then of course Liverpool still wins the league. It's just like anything can happen in any one given game, but that doesn't tell you anything. Anybody can tell you one different name. Yeah, 7-2. Yeah, exactly. Same day, that's right. Spurs beat United. Like, yeah, it's crazy, right? It's like Villa wins 7-2. They still finish mid-table, and Liverpool still wins the league. So it's like, well, okay, it happens. It happens. Yeah, just because you win 7-0 one day doesn't mean you're the best team since sliced bread. That doesn't mean anything. All right. Any given day on the pitch, anything can happen. Dylan, I think we both can agree with that, and I think the boys, after that showing against Canvey Island, they definitely showed up for this game because I don't think you want to mess with the wrath of Debs a second time. So I think that there was a lot of soul searching between the Canvey Island game and this Malden Tiptree game. And I think that they finally got it together. Hopefully, once Josh Asude comes back after the 3-game ban, then hopefully things start to get back on track. I think he's the big key linchpin on the right-hand side of the pitch. So he's just the kind of guy you want to have. That speed is just going to constantly give people fits for days. Yeah, it's true. Exactly. One game at a time, my friend. Got the 3 points. We should be happy about that. It's good times abound. Good times aplenty, Dylan. Good times aplenty indeed. We're all about that here. Look, some people won't be convinced because they always want instant results. But hey, it's a marathon and not a sprint. So there's gonna be games like that where you're gonna have great games. There's gonna be games that are gonna be rough. There you are. You're a Chelsea fan. Oh, there you go. And you're definitely a Romelu Lukaku fan. Man, Lukaku is absolutely crazy. That guy definitely deserves every pound he's getting, Strolling Stones. Full foot. Yeah. You know what? You don't need that kind. We need positive vibes on the pitch. We're here to support, but I don't like denigrating another team too much. We all have our arguments against teams we hate, but you know what? At the end of the day, you're supposed to be good sportsmen and good supporters. Yeah, don't make it. Yeah, we don't want that kind of stuff on display. We want we want to show other fans what it is to be good models on and off the pitch. So yeah, Lukaku is a beast, no question. No question, Lukaku's a beast. You can't you can't stop Lukaku. Yikes. You're so savage, Dylan. Oh man. All right, we gotta get going here. All right, we're getting a little bit late here, but again, not gonna be super long here today. So let's go ahead and get started here. Let's do some intros. Let's get going here, ladies and gentlemen. Let's do it. We're doing some probability, my friend. There we go. Okay, let's get started today. Welcome back to Tuesday, end of the week time. Not end of the week time. Hopefully, have a nice weekend. I gotta remember that. Yeah, action. Bam. All right. So today, just as a reminder here, ladies and gentlemen. Yes, just give me 1 second here, Strolling Stones. Just a reminder here, ladies and gentlemen, that everything, the test for chapters 1 and 3, okay, so the homework and test for chapters 1 through 3 is due on the 23rd. So due on the 23rd here. That is when the homework and tests for chapters 1 through 3 will be due on the 23rd. So that's next Thursday, okay? So next Thursday is when that stuff will be due. So please be sure to finish it up by then. I will be posting an announcement here in D2L, sending you guys an email in regards to that, give you a friendly nudge in the right direction, making sure you get that stuff done by next week. Sorry about that, Strolling Stones. If you have a question, go right ahead. Please go ahead and ask. I just wanted to make that announcement there. So, did I state the practice test will look much like the real test? Well, I'm just going to be honest with you, Strolling Stones. The practice test is the real test, just different numbers. That's it. So, if you try the practice test, question for question, it's the real test, just with added bonuses. So, it has like a help me solve this, show me an example. You won't have those options available on the real test, but that's why I suggest, hey, take the practice test. It will certainly help you for the real exam, 100%. And people who've taken the practice test always do better on the actual exam. Nudge, nudge, wink, wink. Also, don't forget here, you do get bonus points for taking the practice test. Pre and post test quiz? No, of course not. None of that stuff, extra stuff, is just extra fluff. Just the stuff on the homework tab and just the stuff underneath the quizzes and tests. That's it, Strolling Stones. Don't do anything extra that you don't need to. I've set it all out for you, my man. All right. No worries. All right. Are there any other questions before we go ahead and get started here? Any other questions before we get started? Doing some new stuff. No, thank you. Reach is like, bam, no, thank you. Okay, got it. Marisa, you're always fun. All right. All right, let's go ahead and get started here. All right, so today, ladies and gentlemen, we're going to be, just to give you another friendly reminder here, we are going to be skipping Chapter 4. So we are not doing Chapter 4. We are going to reserve Chapter 4 here until the end of the semester. So at the end of the semester, we're going to be doing that's the last chapter we'll do with Chapter 4 because it's a little bit more relevant for the last couple of chapters more than it is this chapter here. So we'll talk about that at the end of the semester here. So we're going to go from Chapter 3, which is what we did last time. We'll skip Chapter 4 until the end. And then we're going to go to Chapter 5 here today. So Chapter 5 is going to be our next chapter here. So we're going to be doing the first section here of Chapter 5. And in this chapter here, for Chapter 5, we're talking all about probability, okay? Everything here is referring to probability. So today we're going to be talking about some of the basics behind probability, looking at some basic questions, and answering them together, okay? Just that simple, I do promise you. So let's go to the big board here, and let's go ahead and take a look and see what we're talking about. Bam. Yes, here we are. All right. So let's take a look here at question number 1 here from section 5.1. All right. So question 1, what is a sample space? So the notation for a sample space here is the letter S, all right? And again, a sample space here is the collection of all possible outcomes in a probability experiment. So let's put it into perspective here, at least to talk about what that actually means. So the example I put here is flipping a coin. If you flip a coin here, again, you flip a coin, here's a coin, right? Here's a quarter. Now, there's only 2 sides to a quarter, right? There's heads, and then, of course, you flip it around, and there's tails, okay? You flip a coin. Those are your only 2 possible outcomes when you flip a coin, and then that's all you're going to get here at the end of the day, heads or tails, okay? So that's what we get here in that particular case. Now, again, what are some other sample spaces? So think about this. This here is a 6-sided die. Okay, so as you can see here on, I know, a little small on the screen here since I'm in the corner. But here's a 6-sided die, and a 6-sided die only has 6 possibilities. 1, 2, 3, 4, 5, or 6. So we roll the die. It comes up with a random number, right? But those are one of the random possibilities here that we can get after rolling a 6-sided die is anything between 1 through 6. Okay, so that's certainly possible as well. Okay, now let's talk about the next part here. Let's talk about number 2 and where we're going to start linking some of these things together. So number 2, what is an event? Okay, so an event here is a collection of outcomes from a probability. So this could be more than one outcome here. All right. Now, what is a outcome here, or an event or an outcome or outcomes that can happen here in an event? So for example, here I put down rolling a 4. So if you roll a 6-sided die and you roll a 4, that's an event. Okay. So, random chance, you roll a 6-sided die, it comes up to be a 4. Fair enough. Okay. Or again, you could put a combination of a couple things. So again, rolling a 5 or a 6. Okay, so you take the roll, and you could roll a 5 or a 6, and then we go ahead and determine, say, a probability based off of that, and then we use it for whatever we need to use it for from there. Okay, now we do assign it a letter here. All right, so sometimes you're going to see this in the textbook here, so that's why I kind of want to make you aware about how this works. Is you'll see the generalization for event here is the letter E for event. Okay, so the book here uses a E for event quite often, or it also uses A, like capital A. You can assign any letter you want, so you may see capital A, capital B, things like that. So those refer to, again, specific types of events. All right, but it can literally be any letter, but E and A are typically the 2 most common letters that you see most of the time. So just making you aware about how that's going to work. And it's not too hard. Again, we'll see that in action as we continue doing this chapter. Okay, no problem. All right. Any questions so far before we move forward? Nope. All right, let's move forward then, because the next couple parts here are going to be pretty important. All right, so let's look at number 3. Okay, so number 3 here on the handout talks about what is an unusual event. Now, this is going to be something that will be appearing here, not just in this chapter, but in future chapters as well, because the book will actually ask you questions on the homework as well. We'll ask you, is this blah, 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 a unusual event. Okay, now, what exactly is the metric here for an unusual event? This happens where the probability of the event is less than 0.05 or 5%. Okay, this is incredibly important to note. Again, it is a hard metric here that we use for what we call an unusual event. So something unique or unusual, less than 5% is going to be our threshold here in this particular instance. So please keep that in mind when you do see questions that do ask you this, say, is, such and such thing an unusual event? This is essentially what they're asking you to do, is finding, saying, a probability of less than 5%. Okay, now, having said that, let's move to question 4 here, and then we're going to look at some examples here. All right, so number 4 is, what is the notation for a probability model? Now, the notation that we use here for probability is we use the letter P, so capital P here, representing probability. And then inside the parentheses, we put the event, whether it be A. Again, A, we said, is an event letter. Again, capital A. You can put capital B, capital E, whatever you want. Okay, but that event is going to be inside the parentheses. So we say the probability, for example, to read this would be the probability of A. All right, just as a quick example here. Now, let's go ahead and see how we can figure out probabilities from a generic standpoint. Again, we're just going to use simple logic here. I haven't really introduced too much about the specifics yet, but I think that we can probably figure it out. It shouldn't be as hard as you're probably making it out to be. So let's go ahead and take a look here and see how this works. Okay. So let's say we have a 6-sided die. Let's go with something simple, all right? Let's go with the 6-sided die. All right. Let's go with the probability of rolling a 4. All right. So, can anybody tell me here, what is the probability that we roll a 4? What are the chances that we take a 6-sided die like this, like in my hand, and we roll it on a fair die, it's a fair die, and we roll a 4? Okay. Everybody, 1 out of 6? Okay, very good. That is correct. Okay, a 4 out of 6. Oh dear. So let's talk about that, Sanla. All right, it is going to be 1 out of 6 here. Oops. All right. So let's talk about why that is. Okay, let's break this down here. Now, by conventional thinking, and what you guys have said is absolutely right. And let's break this down a little bit further here from that pace of conventional thinking. Again, just looking at it from a generic point of view. This one here basically reflects on how many 4s are actually on the 6-sided die. So again, this basically says, well, how many ways, how many 4s, essentially. So there is going to be only 1 4 out of the 6 possible sides on the 6-sided die. All right, that's only one way we can get a 4. Out of the number of possibilities, so again, the number of possibilities on the 6-sided die. So the total number of possibilities on a 6-sided die is going to be 6. Okay, so number of 4s, how many ways can we get 4? Only one way. And out of 6 possible ways on what we get overall on the 6-sided die. All right, seems reasonable. All right, let's try and take a look at another one. How about with probability of rolling a 4 or 5? What's the probability of rolling a 4 or a 5? What do you guys think? The probability of rolling a 4 or a 5? All right. Okay, both are absolutely correct. All right. So, of course, the answer is 2 out of 6 or 1 over 3, whichever way you want to call it. Either way, absolutely correct, right? So there are 2 possibilities, right? We could get a 4 or a 5, so there's 2 ways we can get 4 or 5, right? There's 2 numbers on a 6-sided die out of the total of 6 possibilities that we have. Absolutely fair. And you guys can reduce that fraction down 100%, okay? 2 out of 6 or 1 over 3, whichever way you feel comfortable with. All right, that's fine. Let's go ahead and take a look at another one here. How about the probability of rolling a 4 and 6? What is the probability of rolling a 4 and 6? Probably rolling a 4 and 6. What we got here? Got 1/3. Let's do a little poll here. Let's do a little poll. I know some people are a little confused, but that's okay. So let's go with let's go ahead and put a small short poll here. Put it for 2 minutes. Have you think about it. Let's start this poll here. See what you guys think. All right. All right. Let's see if got about a minute here. And give it a good think, and then decide which one you think it's gonna be. Let's see. Brisa put that. Bill put 0 out of 6. Strolling put 0 out of 6. Okay. Ellie put 1 out of 3. All right. See if we've picked up on it. See, a couple people have, so that's good. So evil. All right. Let this wind down here. Almost done. Bam. All right. So the answer people put is none of the above. All right. And then we had the remaining people put 1/3 or 2 out of 6. Now let's put in the real answer here. You've waited long enough here. So the answer here is going to be absolutely 0. 0 is the correct answer. Okay. 0 is the correct answer. 0 out of 6. Now, one of the things that is going to be very important in this chapter, bar none, regardless of what you think here, is going to be the wording here in this chapter. Remember, it says 4 and 6. Okay, so if you think about it this way, right? Think about it this way. Look at a 6-sided die that I'm holding right now. How many ways can you get 4 and 6 to appear at the same time? Is it even possible for 4 and 6 to appear at the same time? Yes or no? So that's the big question here. Yes or no? Can 4 and 6 appear at the same time if you take the die and you roll it? Is that even remotely possible? No. Okay, there's no way I can get 4 and 6 to appear at the same time. Okay, it's a fair die. Only one number should show up after the end of the day when I roll a fair die. Okay, so again, I will put a word of warning here. This is going to be a pretty big word of warning here. You need to be very careful. Is watch out for wording in make this a super big duder. All right. So watch out for wording here. That's going to be the kind of the biggest thing here when it comes to probability for us to talk about. It's just being very careful about the wording here, depending on whatever it's given. Let's try another. How about the probability of at least 2? Probability of at least 2. 6 out of 6. So it means everything works. At least 2. Maritza. So think of the numbers that are at least 2 on a 6-sided die. Strolling 2 out of 6. 1/2. Okay. Got a lot of answers all over the place. Okay. A lot of answers here. Okay. Let's take a good look here. I think we'll need to answer another question here, guys. So, if I roll at least a 2, think of what happens if I roll at least a 2 on the die. If I roll at least 2 on the die, what numbers are at least 2? Well, that's going to be 2, 3, 4, 5, and 6. All right, meaning to say you're going to have 5 numbers of which you choose from. Remember, at least doesn't mean the smallest number is 2. It means that I rolled at least 2 on the die. So again, your basically outcomes would be 2, 3, 4, 5, and 6. Let me see where you guys are at here, okay? Because I too understand here. This is why, again, I want to point out these guys right now in terms of wording, because like I said, a lot of book problems will use wording here, and it'll be a little tricky to go ahead and kind of interpret. Let me go ahead and see what you guys think. Okay, I'm gonna put up another poll here. All right, so I'm gonna write down a problem here. If you remember their order of operation stuff, like maybe you've seen a problem that looks akin to this. All right. So let's do this one here. I'll put up a poll, a very quick poll. There's only 2 answers people get here for this problem. I want to see where everybody's at. What do you think the answer to this is? 6 divided by 2 times 3. Guys, tell me what you think it is. People only get 1 or 2 answers for this. They get 1 or 9. Tell me which answer you think this is. Is it 1 or is it 9? Again, mark it on your vote there. Trolling, stop trolling. It's not 0. Get out of here. Go ahead and mark it on the poll up top. Pick which one you think it's going to be, 1 or 9. Probably seen these on the Facebook things before. So this is a pretty common question. All right. So 6 people picked 9. A couple people picked 1. All right. So let's take a look here at the question at hand. All right. That's okay, Julia. That's not a problem. So the answer to this is going to be 9. 9 is the correct answer to this. Okay, let's talk about why it's 9 here. Remember in PEMDAS, PEMDAS, everybody knows about PEMDAS, right? Pretty easy stuff. The thing that you want to clue in on is multiply and divide. One of the things that's taught in math, used sometimes incorrectly, is that multiply comes before divide. In fact, that's not true. Just because the word multiply is written before the word division, that doesn't mean anything. What really means is that multiply and divide are the same exact rank. That's something you do have to keep in mind here. We want to break these bad cycles. We want to be sure that you guys at least, this is like the basic stuff with math, but still important to break these cycles here. So in a sense, it's like if I had, let's say I had 6 plus 2 minus 3, or 6 minus 2 plus 3. If I had, say, plus or minus instead of times and divide, you would go ahead and add subtract from left to right. You would just say, okay, 6 plus 2, which is 8 minus 3, which would be 5. Or 6 minus 2, which is 4 plus 3, which would be 7. You'd be like, okay, I'm just going left to right, and I'm just going ahead and adding and subtracting. My point of contention would be, why don't you do the same here? There are no parentheses here. I could just go left to right. So essentially I do 6 divided by 2 first, and I do 3, and I multiply that by 3, and I get 9. So in this case here, I want you to kind of understand that, yes, we want to break these kind of habits here and kind of want you to think. Basically, my point is that I want you to kind of think from a different perspective now. Okay, so wording is going to be important, so you have to look at it from a different perspective here. I know it's a little bit tough, but we want to kind of shift our focus to the right perspective here in order to get our proper answer here for probabilities, much the same way we do these basic kind of problems here, like using order of operations. Same deal. Okay, so just want to kind of clear those up there, so that way, again, it makes it significantly easier down the line as we continue to do these problems. Are there any questions about that? All right, let's try another one. Let's try another one. Okay, I think another one's okay to try. Let's then. Yeah, sorry. My bad. Let's go with it. About the probability of less than 2. What's the probability of less than 2 on a 6-sided die? Probability of less than 2. All right. Good. So the answer is going to be, in this case here, make me proud 1, just 1, make me proud. Remember, I need 1 out of 6. 1 out of 6, okay? So I need a fraction for that. Make me proud. 1 over 6. So 1 possibility over 6. All right. Okay, so that's correct. Again, the only possible number that's less than 2 is 1. Okay, so that's it. All right, so again, just being a little careful. Again, there is a difference between at least and less than. There is a significant difference. We'll see other wordings. We'll see other wordings and other examples for sure. Yeah, make me proud. Important. You got to keep it as a fraction. Okay, some number over some number. Okay, keep it as a fraction if you can figure it out as a fraction. All right. Now, having said that, let's move on. Let's go back here for just a second. I'll go back to the paint tool momentarily. Let's talk about some of the properties that we can find out here in these cases. Oops, wrong one. So let's look at number 5. Number 5 says, what are some properties of probabilities? So the first thing that we have to recognize is that the first property of a probability is going to be that the probability, regardless of whatever event that we're looking at, has to be between 0 and 1, where 0 represents, say, 0%, and 1 represents 100%. Okay, so the probability has to be between 0 and 1. So if you get probabilities that are negative or then are bigger than 1, then you know you went wrong somewhere. So that's something that we want to avoid at all costs. Now let's take a look at what's written after that here. It says if the sample space S, which is A1 to AN, essentially all the possibilities. So for example, for our six-sided die, it'd be 1, 2, 3, 4, 5, and 6 as an example here. Then the sum of all the outcomes in the sample space must equal 1. So meaning to say the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 6. We add all those properties together on a six-sided die. That's going to equal 100%. All right. And I put a little note here. It says, note, if solving, express as a fraction, if possible, and do the division to reduce confusion. What this basically means is that if you get a nice fraction like 1 out of 6 or something like that, just leave it as the fraction as is. But if you have more complicated numbers as your fraction, like, 1360 over 1000, 1360 over 1974, whatever, well, it's probably better you go ahead and just change it into a decimal. And don't forget here, the decimals that we are going to reflect here in this case will be out to 4 decimal places, okay? So please keep that in mind. That was our standard MO that we stated back in Chapter 2, and we're still going to once again here keep that the same way here when it comes to probability. So it'll always be 4 decimal places here, okay? So don't forget about that. All right, so that's fine. Okay, so that will leave us here to number 6. Number 6 says, how do we compute probabilities of equally likely outcomes? Okay, so just like rolling a six-sided die, all right, each number on the six-sided die, 1 to 6, has an equal chance of, being an outcome because it's a random chance that from 1 to 6, they all have a 1 out of 6 chance of showing up on the die when we roll a six-sided die. So that's what we're talking about, equally likely outcomes. So an experiment has n equally likely outcomes, and if the number of ways that the event can occur is m, then the probability of A, P of A, is equal to the number of ways the event A can occur, which will be m, divided by the total number of possible outcomes, which is n. And as I put the word warning here, we talked about this before, we watch out for the wording here of the event in question. So rolling a 5 on a six-sided die, we just talked about that here, would be 1 over 6. Okay, so nothing, again, just showing this off here in a more formal way from the examples that we just did, and just being able to generalize that in some fashion. Okay, so that's essentially what number 6 is just kind of expressing, is what we just did in our previous examples. All right. Before we move forward here, are there any questions about number 6? We're going to do a few more examples here, but maybe not just with six-sided die, though. Any more questions before I move on to the next example? Okay. No. Emphatic no. Like scream it in my face. No. Okay. We're like, okay. Yeah, we'll talk about that later. All right. Okay, so the next thing that we're going to do here, if we have no questions, we'll go ahead and move forward here. And the next thing we're going to talk about here is we're going to go ahead and let's see here. Why am I not hearing anything? Oh, problem. That thing. All right, there we go. So the next thing that we're going to talk about here is we're going to look at some specific examples here. These specific examples here will be from the textbook. Okay, so we're going to look at the textbook examples here, and we'll see exactly how that'll turn out. So we can see this here on screen. Okay, let's go ahead and we're going to split screen this here with the paint tool. So just want to be able to write out what these results will be. Okay. So let's go ahead and take a look here. This is going to be question number 31, pardon me, with this roulette wheel. I know you can't see 31 page, but still. I don't want a flashcard. Get out of here. All right. So let's talk about roulette. All right. Oh, here we go. So number 31, roulette. In a game of roulette, a wheel consists of 38 slots numbered 0, 00, 1 to 30, and 1 to 36. See the photo. To play the game, a metal ball is spun around the wheel and is allowed to fall into one of the numbered slots. Okay, seems fair. All right, so we're going to go and do letter B here. It says determine the probability that the metal ball falls into the slot marked the number 8. Okay, so in this case, again, we have a roulette wheel. We have a 0, we have a 00, and we have numbers marked 1 to 36. So let's answer the first one here in part B. Again, the probability that the metal ball here lands in number 8. What is the probability that on the roulette wheel that the ball will land in the slot marked number 8? What is that probability going to be? What do you guys think? One out of 38? Okay, good. That's right. So again, there's only one possibility. Again, there's only one number 8 on the wheel. And there are 38 numbers on this wheel overall. Okay, good. That's correct. All right, very good. Pretty easy, right? So again, any number we want to guess, like there's a 1 out of 38 chance that that occurs. Seems fair. Okay, let's talk about letter C here. What's the probability that the metal ball lands in an odd slot? So again, so you spin it around and the metal ball lands in an odd slot. Lands on an odd number. What would be the odds here in this case? Ball lands in the odd slot. Odd number. What do you guys think? "19 of 38, okay. So you're thinking that it's a half there. 17 of 38, okay. A few answers here. Let's get a few more answers as well. "17 and 19, okay. 20 of 38, okay. Let's keep going here. Before it says 19 of 30, okay, no, that's if you need to change your answer, you have your reasons. 19 of 38. All right, so one thing I can totally agree with, let's go over the part I think everybody got, is that we do know there's 38 numbers total overall. So that's fine. Got no problem with that. Easy enough. Agreed with you guys 100%. Let's take a look here at what the top number is going to be, because of course that's the point of contention. We've had a few answers here that said, oh, That's okay, Horace. I'm just repeating what I'm reading. That's all. I don't mean to influence your answers in any way. It's not by not on purpose. Trust me. Uh, so we have again over 38. So the answer here is going to be a number that nobody wrote. The answer is 18 over 38. This is 18 over 38 here. All right, 18 over 38. Now you're probably wondering, huh? 18 over 38? Like, why is that? Well, let's talk about the reasoning behind that. We want an odd number, meaning that number has to be like 1 or 3 or 5 or 7 and 9 and so on and so forth. Now, there are 18 numbers in between 1 and 36 that are odd. Okay? And 0, but more importantly here is that 0 and double 0 do not count as odd numbers. They're their own unique guys. As 0 and double 0 do not count as odd numbers. So because 0 and double 0 do not count as odd numbers, that means there's only 18 odd numbers that we need to take under consideration overall, the ones between 1 and 36. So we have 18 out of 38, and then there you go. That's how we find out the probability of the odd in that case. And by the way, we're also going to explore one thing about roulette. Is that you should if you were in a casino, ladies and gentlemen, is to never play roulette in a casino. Just don't even bother. Roulette is the absolute worst game in a casino. So you are wasting your money and wasting your time if you are going to play roulette in a casino. Do not. We're actually going to explore how much money you actually lose at a roulette wheel. So we will figure that out in this chapter. But yeah, roulette is a terrible game, folks. An awful, awful game. If you're talking the best game in the casino, the best game in the casino is poker. The best game in the casino is poker, 100%. Because in poker, you're not playing against the house. You're usually playing against other players. Okay, that's the only thing I would say you could play at the casino. Slots are pretty bad. Blackjack, I know most people think of blackjack, and blackjack's not that great either. So blackjack is probably as close as you're probably going to get. If you're playing against the house, but even then, it's not that great. So play the lotto. Play the lotto. Oh boy, play the lotto. Actually, oh, it looks cool. That's nice. Looking cool and actually playing it are two different things. Looking cool is so amazing, but let me tell you, actually playing it is just horrible. It's horrible. Okay? On a roulette, let me see if I can find the picture here. Let me show you why it's actually horrible. Look at a roulette table. Okay, let's see if I can show you how this works here. So there are several issues with the roulette table that you can certainly take into account. All right, so here's a standard roulette kind of table-ish type of thing. Let me move my face out of here. Second. So take off my face here for a moment. So here's a standard roulette table. Now here's the problem, right? You can literally put in like whatever amount of chips that you want. So you can put it on red, you can put it on black, all right? You can put it on 1 to 18, 19 to 36, you know, the first 12, second 12, third 12, whatever. These odds here, if you put like on from 1 to 36, the odds of winning if you get exactly on that particular if you get it exactly on that particular guy, for example, all right, from 1 to 36, the odds of what you get back is 36 to 1. So here's the problem. If the odds that you get back are 36 to 1, you've already lost. Okay? So the reason why you've already lost is because there's already 38 spots on the wheel. So you actually are getting paid less for hitting the exact number at the end of the day. Really, you should get $38 for every $1 you bet if you get exactly that number. But they actually don't include the 0 and 00 as part of your payout. So essentially, you're already down an extra $2, even if you put like 1 on 13, which is absolutely criminal. So that's, I mean, right away you could pretty much tell, with 36 to 1, you're already in a losing proposition. That's why, again, you could try and figure out strategies to make money on roulette and stuff, but it's just, I don't know, you're just asking for trouble. You're asking for a lot of trouble. So I avoid this game like the plague, because it's just not worth it at the end of the day. Definitely not worth it, like, ever. These odds are so bad, they are already against you before you walk in the door. It's just bad. However, I will say this. If you're running an illegal gambling operation, and you have a roulette wheel, and people want to play at your roulette wheel, then you're a very happy gambler. Because then somebody is going to be a sucker at the end of the day, and you know it won't be you, because you'll be collecting the cash off of them. Hey! Now, do I recommend you running an illegal gambling operation, ladies and gentlemen? The answer is no. Please don't. You don't want to be busted by the police. Okay. Have the tables and everything. Oh my god. But yeah. Hilarious. All right, let's go ahead and try the next one here. Okay. All right. The next one I'm going to do here is I'm going to do number 35. So let's do number 35 here. That's the next one. Okay, so 35 is a college survey. So in a national survey conducted by the CDC to determine college students' health risk behaviors, college students were asked, how often do you wear a seatbelt when riding in a car driven by someone else? The frequencies appear in the following table. So again, we have never, rarely, sometimes, most of the time, and always. Okay, so let's take a good look here at let's take a good look here at number 35. Let's look at a couple probabilities here. Let's look at the first probability. Probability of what's this probability of wearing a seatbelt most of the time? What's the probability of wearing a seatbelt most of the time? Okay. What do you guys think? Let's again, we're gonna put it in fractional format first. So the probability of wearing a seatbelt most of the time. Tell me what you guys think. How many people, according to this table here in number 35, are wearing a seatbelt most of the time? Let's at least do that first. Let's go one step at a time. How many people are wearing a seatbelt most of the time according to this chart? Alright, so Brisa says 1,257. Okay. 100% agreed. Alright. Alright. So 1,257 people wear a seatbelt most of the time. Seems fair. Out of how many people? So let's think about it this way. How many people did we survey in order to get these results? How many people did we survey to get these results? Okay, very good. Both are absolutely spot on here. right? We're going to take the frequencies of each one of these categories, and we're just going to add them together. And most or all of you are already really on track here, so that's good. And we're just going to go ahead and add these together. And so everybody is correct here in saying we certainly do get 4,776. Okay. Now this is a pretty complicated fraction, no question. 1257 over 4776. So in this case here, I want to convert it into a decimal to see, exactly what we're working with here. So what is 1257 over 4776 as a decimal? And remember, round to 4 decimal places here. So can anybody tell me here 4 decimal places for this particular fraction? Uh, 2632. Okay. Got that? Okay. So like everybody else got exactly what that same number there. Good. Okay. And so 0.2632 would be your final answer to better reflect the odds of wearing a seatbelt most of the time, according to this frequency distribution. By the way, always wear your seatbelt. That's a good thing. PSA time. Okay, any questions over basic probabilities? Any questions over basic probabilities here so far? We'll have to talk about one more thing here, but no, sir. I hope it stays this simple. It will to a degree. I hope it will. Question mark, question mark, question mark. The skepticism already starts. Okay, that's fair. All right, let's look at number 7 here. We got one more question to do here, and then we're going to stop for the stop. That's where I stopped for the first one, so we'll stop here. All right, so let's look at number 7 here. What is the empirical method? So the empirical method is pretty simple. At least we're talking simple stuff here. It is simple. That basically usually involves a large amount of trials of an experiment. So the best way to describe this is the example I have here. Flipping a coin to determine the probability of getting heads is more accurate the more flips you make. Now, essentially, here's how it works, right? We know that from a coin, we have a 50-50 chance of arriving at heads or arriving at tails. We know that for a fact it's either 50-50, just pure random chance on how it works out. You get 50% heads, 50% tails. Seems fair. The problem is, and let me go to my other cam here because I need this cam. Right. The problem here is, in this case, is with this coin, is that let's say you flip it, let's say you flip it 10 times, okay? You flip this 10 times. And if you flip it 10 times, what happens here in this case? You flip it 10 times, well, you could get 7 heads and 3 tails. However, flipping it 10 times doesn't necessarily reflect the exact 50-50 nature of a coin, okay? Because it's, again, 50% heads, 50% tails. So maybe instead of flipping it 10 times, to really reflect the 50%, 50%, because, again, it's too small of a sample size as 10. Instead of flipping it 10 times, maybe flip it 10,000 times. And if you flip a coin 10,000 times, you'll see that the coin here gets closer and closer to a 50%, a true kind of 50%, 50% heads and tails at the end of the day. So this is kind of like what we talked about before. We said, hey, if you have a small sample size, that isn't going to tell you much at all. Okay, you could get, at the end of the day, you're going to get more random chance inside of those 10 trials. But if you flip it 10,000 times, then it's going to average itself out over that period of time, over that many flips. Okay, it's very extremely highly unlikely that you're going to get a skew in one direction or another. It'll pretty much flatten out to a 50% kind of cut after trying it 10,000 times. So that's why a lot of times you hear about scientists running millions of simulations, okay? Because one simulation isn't going to tell you anything. Millions of simulations will certainly say, hey, this is where the expectation is, of this scenario underneath these parameters or whatever they're using, whatever the case may be. Okay, so used in sports all the time as well. So again, having an empirical method, having a sufficiently large enough sample size will help you make a proper conclusion. So that's exactly what I've put down here. You need a sufficiently large enough sample size to make a proper conclusion. And we'll be looking at that in various concepts here, not only in this chapter, but in subsequent chapters as well, where we are going to be making sure we have a large enough sample size to arrive at a particular conclusion. So that is referring to the empirical method. All right. So that is the end of section 5.1. Does anybody have any questions about this section here? Science and math. There you go. That's right. All good. All right. No. Excellent. No, thank you. Okay, gotcha. All right, so this is where we're going to stop here for today. We're going to continue where we left off here. We're going to start at question 8 here, which will be the next section. We're at a really good pace here so far. Okay, we're pretty ahead since we're in week 4. Being in chapter 5 is actually a really good pace. So we're on good track, guys. We are on really good track here to finish without too much trouble. So, yeah, we're on a good pace here. Again, if you're keeping track of the homework assignments, I would start at chapter 5 homework, but your priority first should be doing the chapter 1 through 3 assignments and the test. So be sure to do the chapters 1 through 3 homework and the chapter 1 through 3 test first, and then go ahead and start with the chapter 5.1 homework after that, once you get that finished and squared away. Okay, so that should be your first priority, and then move forward and do the section 5.1 to kind of keep track with the new material. Okay, so that's where you should be moving forward. All right. Really good job here today, everybody. Very nice work. Excelente. All right. But to the big board here. There we are. All right. All right. Excellent job here today, everybody. You guys are absolutely fantastic people. Absolutely fantastic people. I love each and every one of you. You guys are so great. Okay, you guys, thank you so much for being patient with me today. And you guys should pat yourselves on the back. You guys did absolutely outstanding in those examples. All right. Don't worry about that. Thanks, Dylan. I appreciate that. Thanks for lurking in. Hopefully you learned a little bit here today. All right. Everyone, have yourself an absolutely wonderful night. All right, please rest, relax, take care of yourselves, and we are going to be back here at the same time, same place on Thursday, okay? Thursday we'll be back, all right? We'll be back same time, same place. Appreciate that, Dylan. Appreciate that. All right, thank you guys. You guys are rock. You guys make my day. I could tell you that right now. You guys make my day 100%. All right. And we'll be back. If you guys have questions, of course, feel free to email me. Okay, I'll be on Discord. You guys know exactly where to find me. Not that hard to find, guys. I promise you that. All right. All right, everybody. Take care. And as always, stay safe, stay healthy, but most importantly, stay sane. All right? Have yourself a wonderful night, and we will see you in a couple days. All right. Take care, everybody. See ya. All right. Bye. Bye, everybody.